we take the area of the big circle and subtracted the area of the little circle in order to get the area of the shaded region right in here. The shaded region is not a circle, so we can't use pi r squared there. That's why you cannot subtract your two radiuses and use 2 as a radius. That's not a circle. So we have to subtract the little circle from the big circle. And there's a couple ways you can do it. You can put it straight in your calculator, or you can separate it into 2 figures and subtract. Either way, you'll get 50.24. So in this problem, we're going to take the big circle and subtract the 2 little circles from it in order to find the area of the shaded region. And I've broken that up for you. We know that the big circle, its radius, is the same thing as the diameter of the little circle. And we know the 2 little circles are the same area since they both have a radius of 3. So we can just double the area formula and say 2 pi r squared instead of pi r squared, since they both have a radius of 3. So we can split this off into 2 problems. We can find the area of the big circle is 113.04, and the area of the 2 little circles is 56.52. Subtract and find the area of the shaded region is 56.52. And we notice that the 2 little circles is half the area of the big circle. Or we can put it straight into our calculator. We can put the area of the big circle, 3.14 times 6 squared, minus the area of the 2 little circles. So that's 2 times 3.14 times 3 squared, and hit equals. And you can put it straight in because the order of operations will do the multiplication and the exponents before it does the subtraction, which is what we want it to do. If we're not sure, however, about the order of operations or feel insecure about it, we can always put parentheses into our problem, and that will emphasize what we want done first. And it's okay if you put it in and it's already going to do that first. It won't mess everything up. Okay, so after you find the area of the rectangle, which is base times height, and the 2 circles, then you just subtract. Now to find the base, what we did was we figured out that the diameter of all these circles is 20, because over here we see 20, and that is the diameter of the circle as well as the height of your rectangle. So since our diameter is 20, the radius is 10, so we see a 10 here, a 10 here, and then this is 20. We add all that together to give us 40 as our base. So we do 40 times 20 to get our base times height, and that gives us 800 for the area of the rectangle. For the 2 circles, since they are congruent, and we have 2 circles because we have a whole circle and 2 half circles, we're going to multiply 2 times pi r squared instead of just pi r squared, since they have the same radius. So we're going to multiply 2 times 3.14 times 10 squared, and that gives us 628. When we subtract, we get a total area of 172. We can put this straight into our calculator if we like by saying 40 times 20 minus 2 times 3.14 times 10 squared, and that would also give us 172. If we choose to do it this way, we need to be very clear what we're putting in the calculator. This is our rectangle, and this right here is our 2 circles. To break up number 23, what you're going to have to do is notice the figures. First of all, you have 2 rectangles that have the same area. These rectangles have a 10 as their base and a 15 as their height. You'll see the 10 over here. So this height is also going to be 15. Then you have a big rectangle in the middle that has a height of the 15 plus, since this is 10, this over here is 10 also because those are radii of the same quarter circle. So this is also 10, that's 15. So we know that the height of the big rectangle is 25. And we know the base is going to be this length of 40 at the bottom minus the 10 right here, because since this is a rectangle, opposite sides are congruent. So that gives us a length here of 30. So we're going to end up with 25 times 30 for the base and height of the middle rectangle. Then we have 2 quarter circles. Whenever you see a figure that looks like this, it looks like it has a right angle, that means it's a fourth of a circle. So it's 2 quarter circles. So 2 times 1/4 equals 1/2. They both have a radius of 10. Both sides here can be considered 10. So they both have a radius of 10, so they can be considered out of the same circle. So we can say 1/2 of a circle with radius equaling 10. So down here I'm going to write 1/2 a circle. So my formula is 1/2 times pi r squared, which is 1/2 times 3.14 times 10 squared. Now, since we're trying to find the area of the shaded region, I'm going to find all of these areas and then add that together to find my total area. On the next problem, I want to show you just really quickly, this is a radius of 10. We have 1/2 a circle with a radius equal to 10. Then we have a quarter circle, but the radius is different, so we have to keep these as separate areas that we add together. So the radius for this one, we take this 10 here, that radius of 10 there, and that radius of 10 there to see that the 1/2 a circle has a diameter of 20, and that diameter of 20 for the 1/2 a circle is actually the radius of 20 for our quarter circle. And then we're going to add those two areas together.